Hey, welcome back to Made Up of Wires, where we're decompiling Castlevania Symphony of the Night. This is what we're going to be working on in a little bit. Not that, but something similar. You can go to sun.z.dev to learn more about the Castlevania Symphony of the Night decompilation project. We've been working on primarily US and PSP EU. I've mentioned this before, but it is worth repeating for anybody who hasn't watched the stream before. I'm way over to the left, aren't I? I have something stuck under my chair wheel. The HD version of the game, except for DRA, is identical to the JP 1.0. We haven't worked on JP 1... we haven't worked on JP 1.0 because all these are identical. And I've been wanting to get this updated, and I should be able to do it soon. I just got a copy of JP 1.2 and should be able to add 1.0. 1.0 is already there. I should be able to add 1.2 as well, and maybe even 1.1. We'll see. So I've been doing a lot of research, I guess, on the JP versions of the game and seeing what the timeline there was. My current understanding is that JP 1.0 was the original release, and 1.1 was built about 2 weeks later and had some game-breaking bug fixes in it. As far as I can tell, though, it's, well, at least on the secondary market, it is not the bulk of discs. And if I ever acquire one, I'll tell you how to tell if your disc is a 1.1 or 1.0 version. And then JP 1.2, and I was possibly mistaken, we'll see. So I wanted to find those discs as well. 1.2 you can get in the JP version of Dracula X Nocturne in the Moonlight, the best. That's like their greatest hits series. And then there's a fourth release, and the question is whether that release is the same as the best release, called PS1 Books. That was released in 2003, and the Google seems to think that the best release is the same as the PS1 Books release, but Google is often wrong about things like that, and I just want to verify for myself, I guess. It would be interesting to see if there was another one. I've never been able to track down the HK version. I've seen somebody on Reddit with a copy of it. I can't even find it on archive.org or other suspect sites. Mostly I don't care about having an ISO or a bin or anything like that. I just want to see. I've heard that it's the US version of the game, but put on a JP region disc. And that would be relatively easy to identify based on file timestamps and sizes. The US prototype from E3, I will never see that in my life. I'm pretty sure of it. As well as probably never see the PSP Korea version either. But that would be an interesting one to see. We don't have PSP US up here, which is somewhat interesting. The EU version of the game, and the reason we chose the PSP EU version of the game, it was the first version to have multi-language support. We also don't have the two Xbox versions of the game up here. We have a dump from Ghidra from that executable, and the code looks like it does in every other version of the game. The interesting things, I think, on that version would be what does the PlayStation SDK shim layer look like? I'd be interested in seeing that. And were there any other changes? To the best of my knowledge, it works exactly like the US version, just with no load times. So probably pretty similar. It might be interesting to see if like the cell function was stripped there. And actually looking at HD or any of the other JP versions, we might be able to find that function as well. Maybe even Saturn. That would be interesting. There's one function in Cell that we haven't been able to solve yet. So we've been working on Olrox, and I think we'll get back to that. A lot of work being done on the second castle. That's coming together really cleanly. So I haven't done any of that. I haven't been spending a lot of free time on Symphony of the Night Decomp. But what other news is there? I had a change to get PSP weapons, and are the PSP weapons, I doubt that they're ever going to be, oh, they are consolidated here, that's good. The PSP weapons are interesting because each one is a separate overlay, and there are, I think, how many weapons are there? There's over 100. Uh, 100 if you count left and right hand. So not all weapons can be shared or split between hands, but in some are double-handed, I believe. And each weapon on the PSP version has its own overlay, which is different from the PlayStation version. Hey Roman, good to have you. Let's get into it. So we're working on Olrox. Let's see if I have a duck station that's usable. And if I do, I do. Let's put a breakpoint in this function that we've been working on and see if we can tell what it is. So it seems to have something to do with the after image, but also the excuse me, the second phase of the fight. We're going to focus on Dornan was working on this. Thanks, Dornan. Appreciate it. We'll keep working on it, and first we'll go over to DuckStation. Open the CPU debugger. And we're going to put in a breakpoint for executing here and see if we can trigger that. I've already defeated Olrox in this save state, so let's go back to the previous state and start that fight again and see when or if we can trigger this. Break your table, Olrox. And like I said, I think it has to do with his true form, and yeah, we've already seen it. So it has something to do with the effect related to his true form. And I'm going to disable the breakpoint and watch the animation, because there's a comment in there about the effect not working, and I just want to see what, so there's scaling effects that come in. Is it just the scaling effect, or is there something else that we can tell is going on there? And really, yeah, it seems like just the scaling effect. Let's see if that entity is gone now. Yeah, now the breakpoint's not being hit anymore. So whatever the function is seems to relate directly to. Let's see if I can. Yeah. We'll do it one more time, and what I want to do is re-enable the breakpoint about halfway through the animation, and I'll just poison him, because that's much faster. There we go. Okay, so we've hit the breakpoint. I'm going to disable it until we get about halfway through, and then re-enable it and see how far through the animation that goes. All right, so we're there. It might be the morphing or fading between as well. Yeah, we're still hitting it. See all the polygons that make up Alucard's mist? And we'll disable it for a little bit longer and go right to the end, or near the end. I want to see when... Stop hitting it. It'd be nice if we got a full frame draw for all the Alucard or Olrak's primitives. Okay, and now it's gone. So just something that's being done during the transformation. And should we look at S. Dornan's? I want to see what, if anything, he's having problems with. Yeah, I noticed this earlier too, and we talked about it last week. The load half unsigned. So one of these appears to be the wrong type. It may be something as simple as that. It doesn't look like it. And I don't think that let's look at the F-32 Val, which is, I think everything in here is signed. So I'm not sure what's causing the load half unsigned. Close that and go back to ours. It could be being cast. That could be the issue. But let's go back there and figure out what is missing otherwise, and I'll stick with the PSP version. And we'll go through again. So definitely closer on the PlayStation version, but not quite the right thing yet. 26, I'm gonna have to refamiliarize myself with this. Looks like we're storing the prim index to the stack. I may need to go through and figure out which of these variables I can still get rid of, because it looks like I have a few too many, and any of these stack pushes are going to be related to that. Same with the moves. So it may be a time to, all these are stack pointer differences. It may be the time to figure out variables. Oh, this is a hint. 108. This is a create entity. Not a great hint, unfortunately. This is, instead of 33, this is going to be a global. So we're going to define that for the PSP as a integer. Oh, actually, we know what the global is. This is more stack issues. Not concerned with that. Stack issues. 135 is possibly interesting. Let me make sure that I fixed primitive. Primitive on the PSP, it looks like I have, is different. An extra 32 bytes of padding, and that looks fine. Hey, Fred. Good to have you. It's going okay. Let's look at these 132. I may have to, I don't really want to, but I may have to go update all of my draw end structs. And I just don't want to because it's boring. The only reason, I guess, would be to figure out what might be going on here. It looks like this is just prim getting passed instead of an offset into prim, but maybe that offset is being pulled somewhere else. So I expect a S0 offset by 14 somewhere else. We can look at this S8. Yeah, here we go. So this looks like drEnv is pulled out way up here. Do I have a, I don't even have a variable for that. It's pulled out before. Hey, holder of ashtrays. Only minimally, and Eldritch was in chat. The question is, have I seen the PlayStation Recomp? Eldritch was in the chat last Thursday, and we talked a little bit about it. Yeah, definitely cool. And I think what we talked about was, beyond other things, is it possible that we could start like Ship of Theseus replacing functions in the recomp with things that we've decomped? And that would be possible. And I don't know if I have enough time to really think about that at the moment, but there could be some interesting things to do there. So down here with this drEnv pointer, like we need to pull that up and then pass the pointer. And on the PlayStation, you wouldn't be able to tell something like that. That gives us a new variable, which is unfortunate, but we'll clear those out in a little bit. It looks like this load may be happening later. We're loading offset 84, but it's not being done until a few instructions later down here. So let's see if I can get that right. That looks a little better. Those ordering issues, again, won't happen on the PlayStation, so we'd never see it otherwise. 159. This is possibly an ordering issue as well. So I'm 4 bytes off. This may be Prim 3. We don't have a Prim 3. 4 bytes off the wrong way. Let's try prim1. Okay, that's correct. And then what is... It looks like this is being loaded into prim, which I guess makes sense. I can buy that. And then we're setting prim draw mode. We don't control really the how the assignment is done. That'll happen in a little bit. Moves I'm not too worried about. The shift right arithmetic, yeah, here's a bunch of stuff that wasn't working. I think that probably got resolved. I vaguely remember this from last week. I think we're still doing the shift by 16 and then masking, if I can remember correctly. And the shift right arithmetic versus shift right logical is what was tripping me up. This could be a division by 65,536. I think that's the magic number. This is generating very different code, though. It's generating the code for the division instead. So we see the code gen puts this load upper immediate, so that's taking the 17th bit and setting it, because you can only load 16 bits at a time in MIPS 32, in MIPS 64 as well. And so it sets the top half, and then the bottom half. The top half is 1, the bottom half is going to be all zeros. So it does that load there, and then it doesn't actually use that V1 register at all. The other thing is we have a SEH instruction, and that does get generated, but slightly differently. Let's look at, I'm going to cheat a little bit and look at S. Dornan's and see if what he ended up putting for that, if anything. Oh, he ended up using pause, and this looks like it works. But the reason I switched away from pause is this load half unsigned versus load half. So I don't think that is going to be correct. On the other hand, maybe it is. The shift by 16 is what's throwing me off. So let's look at pause. Pause is a pointer to the 6E4. Let me get that in context. Right now it's an unsigned 32. I'm going to change it to a signed 32. That doesn't make sense, though. Maybe a signed 16, but that would make sense. So doing a load word, so the sign doesn't end up mattering with a word because it fills all 32 bits. We don't have to pad the rest of the bits with ones for the signed case, or zeros, depending on what the sign is. And we have a rather messy decomp here. I'm going to copy this over because the order of operations is probably correct here. It might not be, but it probably is. And we can recreate based on that. So we have our reference to this global, which is pause. Unknown 0, which is an unsigned 8, which is where the mask comes from. It's a ×2 ×4. That's a little strange. And it's the entire result of that additions dereference, and that's the value that's shifted by 6, and that's what we. And then we're adding the X then. What are the chances of adding in the missing sections from the Saturn version of the Decomp? Renegade of Slack asks. So I don't know if you'd seen it earlier, but Xianamo, who is the one in charge of the project, he was able to port in the PSP Maria into the PlayStation US version of the game. And those games are a little bit more similar. However, assuming that, and I haven't looked closely into the Saturn version, but assuming assets are stored in about the same way, and based on the scaling and everything, it seems like they are, then it would take some work, but it is not impossible. I guess that's as good as I can say about that. The the ×4 is actually implicit because of the size of pause. That's where that's coming from. The shift by 16, that's what's throwing me off. If this was a regular pause, we wouldn't be getting a shift by 16. We'd be getting a load word. Unless it's being done in 2 steps. I'll have to look at that and see what the likelihood of that is. It really depends. It depends how they ended up doing the graphics. So the reason I say that I think that maybe they're similar is because of the aspect ratio differences. I don't know enough about the details regarding that code yet, and it probably is worth looking at and doing a video on later. But what's the best one? So the assets that are the same appear to be the same and stretched in different ways. The Saturn has proper sprite support, but the way that things are squashed, it's not clear if that sprite support was used or if it's just textures on polygons like the PlayStation version. And so I guess all that would have to be figured out. And it's possible that work has been done. I just haven't looked at it yet. People are working on it though. It's still pretty early. No stages have been started yet. And so that's where you would see. The different Maria is being started. But you would see a lot of that additional content in the stage overlays. So the only thing that's missing here is what's causing the shift right arithmetic versus the shift right. Like I said, I would think that that is possibly a division. And we have seen that division by 65536 in other functions in this file. There is possibly some additional support. Let's look at some of these other ones. So here we have, I should actually go back and look at this because I'm guessing it's probably something relatively similar to this. So we do some math, we have some pointers, we have some fun. Then do a multiply by 65,536 and a divide by 128. And that produces some interesting instructions that, so multiplication and division, there are instructions for those, but typically compilers don't use those instructions. They do something more efficient, even when there's no optimizer, like in the PSP version. So this may be a better way to represent it. So guess 7329 is saying arithmetic for signed versus logical for unsigned. I agree with that, but my types are unsigned. Or signed, I mean. Actually, they're not. Now that I think about it. Let's see if we get the right thing. I'm looking for the pause pointer. I'll find it eventually. And for now, I'm just going to cast this, and we'll get the right types later. And that's actually going to fix... Oh, thank you. Yes, 7329. Appreciate it. That makes a lot of sense, logically as well. And so... Sorry. Cast those things. I'm going to make the assumption, and maybe this is a poor assumption. It might be a poor assumption that these are pause, but that might not give me the times 2 that I need. So maybe I'll save that for later. So it looks like I need a +1 in here. And I think I'm going to be pulling a bunch of these out into variables as well. Yeah, that makes a lot of sense. I appreciate it. So I'm going to break these out into index variables, like is done. Actually, this may be close as well. Let's look at what RA1 is. I don't have the shifts though. It's only assigned 16. How many ways will this code use to reference array data? You get a guess. I'm going to try copying this form and see if that produces anything. I don't like it though. That's not the index either. So what I want is for pause to actually be a position. And maybe we can do that now. But I need to make sure that all of the appropriate multiplication, which show up as shift lefts, make sure that all those show up. Let's try it and see. The shift by 16 is still strange. The other thing I should keep track of is where S variables end up being used. It may be a red herring, but it also may not be. S variable, S registers. Sorry. This one is correct, though. And this one be... this would be a +1 outside. Maybe I just keep going. Let's keep going and see. We'll convert all these other ones over and see how that goes. So the shift by 16 is fine. We're converting all of these away from pause. And if I can move them back, great. If I can't, I guess that's fine as well. The coordinates here, I'm trying to think if they're 16 or 20 or 16 or 8-bit. Let's look. It would make sense that they're only 8-bit because they only need to be screen coordinates. No, they're 16-bit. Okay. And anything over 256 is going to be off the screen. But depending on the size of your polygon, that might not make a difference. Get this compiling again and see. I really want to keep this as a pause though. If it's not, that's fine. Nothing I can do about it. Okay, so I have an additional add, which may or may not be happening afterwards. So let's get rid of the plus there. And that now is missing this instruction, so it does look like we're doing it. This probably is going to put it earlier. So we have to do it after this line. And I should get rid of the RA2. And how is that looking now? So our top one is fine. Our bottom one is fine, and we have an unnecessary mask, it looks like. And that looks fine. So I think that's it. Could this be... Could this use pause? No, it couldn't. Because we're traversing 32-bit values. Oh, that's gross, but clean it up. So an odd way to write this. Not my way. But interesting nonetheless. Separate these. And we have these moves, not worried about those at the moment. Let's see where the plus ones are. I need multiply by 2s, it looks like I'm missing for all of these. Because they are coming in pairs, but we're manually forcing the pair. Okay, so this next one is different, of course. Why wouldn't it be? Because I have y0 again. I have y0 again. And is this just operationally different? We're not getting the add here. That's bizarre. Okay, let me fix the grouping and then we'll get rid of the unnecessary adds. Oh, I did all of those wrong. So it's possible that I was right about the plus plus. Yeah, I think I was. So MetroWorks does an odd thing where it wants to keep the operations in order as much as possible. And so even though this plus plus gets evaluated at the end of the entire line's expression, from a like parse tree, abstract syntax tree perspective, it's happening as one of the first things while you're traversing that tree. And so we have to take that value and store it off somewhere else. This makes more sense to me than the odd plus plus, just kind of in between the x and the y. It has to take that value, store it off somewhere, and then it will write it back to the correct register, the A2 register later. And that was what another function in this section looked like. So I'm happy with that. The other thing that I think may be happening, and I have this as well in one of the older functions, excuse me, this is not pause, but it's a I was going to say it's a nested array. And so this kind of looks like that same thing, but it's not really what I want either. So this is generating the right thing, and so I'm happy with it. So we need to go down and basically do the same thing. I think it's identical code down here. I don't think all the variables are the same, so I don't think anything needs to change. And that section should be done too, and that should actually get things pretty close in the PSP. And it does. 214. This is part of the timer decrement, and the timer is being checked. That just goes away. It looks like one of two things could be happening. This may be a multiply. Yeah, probably. A multiply by 256? No, multiply by It is multiplied by 256. However, we're getting this 16 that's being generated. And it's almost like 16 times 16. Or maybe times 4. I'm trying to figure out where this... Oh, we're loading the timer into V1. It's getting plus 16 and then multiplied by 56. That looks right. I don't know why. There may be something else going on here, possibly to look at for the PlayStation version, whether this actually exists or not. This Tempe 0 is, I'm guessing, timer 0. It looks like something I missed early on. But the offset is wrong. Maybe it's brightness. That looks right. And the branch is happening. It's not. This was a GCC optimization, just checking the top bit. It's a greater than 0 check. Greater or equal to 0. Less than 0. There we go. And that probably just checks the wraparound for the brightness. And that probably makes sense if we're morphing two things. Morphing was actually reasonably new technology. But that's effectively what they're doing. Not really, I guess, warping specific points to make them. They're just polygons, and they happen to be moving and fading together. But that's kind of an interesting technique. And does that get rid of Tempe 0? Looks like it, but we don't save any stack space because it's not being used. Probably some stuff down here that will help us with stack space. 235. Let's take a break and see how our PlayStation version's doing. 98%. It's almost matching. Okay, 235's quite a bit different. I moved these around. There may be variables involved here. This this entire expression is pretty gross. And I think when I was looking at the PlayStation version last week, I probably just threw my hands up and said, PSP is just so much easier that let's go look at that. And yeah, we see something that is quite a bit different. So let's take that. What we're looking at is Tempe 7. Where is it being used? Is it going to be in a variable, or are we going to read it multiple times? And we could talk about how or why GCC generates this code, but when the optimizer goes, it's going to do its best to figure out what might be going on. So it looks like we have a divide by 2, so we're loading the this timer target. and then doing one of two things based on the result of that. So let's call temp v1 for we'll get that target time, and we have a little bit of a difference up here. Is that necessary or not? So we have a check for the time on the timer that is missing, but it may be done down here. That's what it looks like. However, it could be unrelated. So we grab the target time. We're going to divide the target time by 2. And that may be happening together, or may be happening on its own line. We'll see. Temp A0. Yeah, it is. It's just a divide by 2, and this is the extra code that gets generated when the division overflows into a negative value, just based on the other math operations that it has to be fixed up. So, not a huge thing there. And then we're checking that target time less than timer 1, and all this seems to go away. And I think the rest of this is correct. So I do think we're missing the timer, and what probably is happening, but maybe not. Let's go back and look. It may be something PSP specific, or it might be something else. We're subtracting 8 from the time. If the lower 7 bits are less than 0, but that doesn't make sense because the lower 7 bits can never be less than 0 when they're masked like that. So sometimes M2C produces inexplicable code, and you just can't follow the logic. So let's go to the tape and see. So it looks like doing a load immediate of 8. So there's going to be 8 somewhere in here. So possibly a divide by 8. To get the time. I think that may be what's going on. It's going into S2 eventually. Let's try this. Let's try timer 1 divided by 8 is greater than 0. Not greater than 0. Let's try this. How playable is the project right now? There are portable builds that are going on, and I just don't have, I haven't taken the time to have them running locally, so unfortunately I can't tell you. There are others that are working on the project that do have those in place, but not me. So I get the load immediate 8. Could be a mod. Yeah, it's a mod. So we're just checking this mod for 0. That makes a lot more sense. It's possibly going into the S2 register. There you go, guess 7329. Appreciate it. It's been a while since I've had a good mod. And yeah, it may be going into a variable as well, I agree. Could we have a mod down here as well? Maybe our divide by 2 is up here. Doesn't look like it. So we are storing a value. This may be the same thing where the evaluation is happening inline, which would avoid some of these additional pushes to the stack. And then we don't have a separate variable for it. Try that. The load order seems backwards. And that looks better. I wouldn't expect the sign extensions here. Because we're probably doing a minus equals. There we go. Not a big fan of that format either. Because we're doing a mutating operation on y1, x3, x2. And then we're doing the assignment of that operation. It's just odd to me. And that's going to get us downright close, I think. Still have too many variables, though. I think that's going to be the last thing, is figuring out where those extra variables are. Because everything else seems to be register and stack loads. All right, so let's see what is the same and what we can get rid of. Oh, was there something down here? Just GAPI stuff. Let's take this over to the PlayStation, see how close we are this time. Very close. I don't like it when there's a 5. I'd rather have an even number. The only differences I expect to see are differences in symbols. And when usually there needs to be 2 instructions for a symbol, and each instruction contributes 5 to that value. So when there's not 5, that means something else is going on. And this probably tells us where to look as well. So we're getting a different register for clip than is expected. Interesting. Different immediate values here. Oh, that's actually relatively straightforward. So, we already have entity +1. We just have to be careful that we're doing the right one. It's a little better. Register issue on 127. And that probably comes down to using wrong variables. Some issues here. 180. Drat. This goes back to all of this garbage. So we have pairs of these are going to be pairs of 32-bit values. So we got to rewrite this a little bit. So instead of being able to do pause and then use the subscript operator here, we're going to say pause plus RA2 times 2, and then use the subscript operator outside. Add a lot more parentheses, and that generates the same code. And then we got to do it again. And now that's correct. So let's take that over and see what PSP does. It's cool with that. This does match what that other function was doing. It's horrible and terrible, but it matches. Mostly what registers are going to be wrong, that's fine. Is there anything I'm excited to do with the project once the source code is completed? There is a couple things, and one I'm not going to talk about because maybe it never happens, and everybody can go on living their life and I'm not a failure if I don't mention it. The other one is I'm slowly procuring the different JP releases, and I want to create a more authoritative timeline of the development. I brought it up before. I don't think this is the current version. But this was the timeline so far that I've created, but it's not completely accurate. And I want to get some additional things. So I have a JP 1.2 version right now. I'll never get the E3 version. I'm not worried about that. There is a Hong Kong version that I really just want to see some file system details. I don't want to procure it. And then the PSP ones, I don't know. So I'd like to, create a more accurate timeline. What I've seen available on wikis isn't completely accurate, and so there's some things about, well, this feature is available in this version of the game, this feature is not available in another version of the game, this changed, blah, blah, blah. And just knowing what that history was, I think, is valuable, and we can create basically a definitive list of these are what actually happened during the development of the game. So this is looking fine and matching, so I'm going to go through and fix all these. I don't think it's going to change the match at all. Because the PSP, it doesn't really matter. I'll do all that at once. And I mean, a lot of people I think are clamoring for making the Saturn content more accessible. And I don't have an issue with that. I think that's reasonable. Maybe fixing the Saturn content. And a lot of people just want, they want a PC version. But I think the recomp is a good step in that direction, but I think there's more that can be done with a true native version. Okay, so that's better. Let's check it again on the PlayStation. PlayStation should be very close. Not as close as I was hoping. Let's see if those registers at the top were fixed. Not yet. So that's around 102. Right, so I'm hoping that getting some of the stack fixed on the PSP version will help with that. So what we have to do now, this is the most boring part, or my most disliked part, I should say, which is trying to find which of these variables don't actually exist and that I can get rid of, and by doing so, fix the stack. So what the original PSP version tells us is that the stack was hex 90 in size, and ours is hex B0 in size. So we have 32 bits. No, sorry, 32 bytes that are on the stack and shouldn't be. How do we do that? We have to go through and look at every register and see where assignments are happening, where possibly assignments weren't happening in the main version. And 24 actually is the first place, but we don't control this code and how the code is generated. So there's nothing that can be done about it. And it's just because we have different variables than the original had, and the register allocation then is happening differently between the two versions of the game. There's too many variables for them each to get their own register. And so we can't rely on that. There's going to be some spill onto the stack. So what we have to do instead is try to find cases where we have known variables, figure out where those exist on the stack or in registers, and then deal with it that way. So the first thing is trim index. Sometimes it's stupid. It's just the ordering of these. Those are the worst. This exists at offset 7C on the stack. The MetroWorks compiler is going, regardless of whether these ever get pushed to the stack or not, it's going to allocate enough space on the stack for all of the variables, which is kind of nice because it tells us how many or what the quantity is and if we're right or not. Yeah, mods will be interesting. Mods are going to be hard. I'll just say that. There's not a game engine, and then enemies, and then stages. So weapons should be relatively easy to mod, because those are just in one place. Bosses should be relatively easy to mod. Maps, maybe. Moving enemies to different places or adding new enemies may be a little difficult. All right, so let's look at var a2_3. That's way down here on 170. What is this up here? I'm not worried about those. Okay, so one of two things could be happening here. It's possible that these are in the wrong order. I should fix the type of this one. which would be a pain. But we are using S1 here, and it looks like, yeah, they are in the wrong word. So let's swap those. And so RS2 is the original's S1, but that does look correct. So pause is S1. And then we know var A3 underscore 2 underscore A2 underscore 3. That one looks like it is S2. And for us, it's S1. We just want to go through and make sure that those are all being used the same. It does look like they are. I'm going to put these close together. Sometimes the ordering of variables for MetroWorks makes a difference, which is a pain. And let's go back down there. So I probably have these backwards as well. And what we should see is S1 and S2 are being used the same way. And it looks like they mostly are. And then we're going to fall down later and figure out some of those are broken. Let's look at I on 173. I is S5. X here on 168. We got S4 for both of them. And Y looks like S3. You see there. So we're 7449. And I move that into the register order 7369. So we got a fraction of a percent just by putting the variables in a different order. Fun. Flip on line 98. We get some sense of where this is just by the order it is on the stack. And it looks like possibly further down. So we can watch, what we should see is our number is getting bigger as it goes down, or sorry, smaller, as it gets closer to the top of the stack. And those can help us. I'm going to move entity and primitive up. Those are often used towards the top. How these others are used may impact this as well, and what order they're in. And this would really suck, I think, if it just came down to ordering. But we know that prim index looks like it's higher. Clip is offset 94. No, 74. Let's rename SP17 draw in. Draw end looks like it's SP stack pointer offset 30. And I may need to go get the PSP version of this. So we're getting different code gen because the size is different between the two versions of the game, and because the size is different, my stack is going to be off. So I probably do have to go get those, which is a bummer. Let's do that. Actually, before we do that, let's copy this over to the PlayStation, see if we're any closer. 100, that's probably a match. So we have a symbol difference, which will wash out. 84 versus 80 on 191. That's a legitimate issue. Do we have prim 0? There may be one more of those lurking. Oh, a register issue on 137. Not happy about that. The T1 versus T0 being backwards is unfortunate. And some still have these register issues about, so not out of the woods quite yet, but a significant improvement. Put this back over here. We should get a little bit better. 0.01. Nothing like having 1/100%. Okay, so like I said, we need to go find draw env and dr env and get the PSP versions of those. For better or worse, we've put these in the PlayStation SDK header. Looks like DRENV maybe is the only one that is different. So we'll grab that. Oh, I do have the correct version of that. Or maybe not. Make sure the other... so I can't have the if-defs in the context and still get M2C to work. M2C doesn't know what to do with them, so it will fail. Okay, so within this we just have rect, and rect should be the same. OTAG maybe. Let's look at that. Okay, what are we doing wrong? Do we not have a U long, maybe? That's what it looks like. Oh, no, we do. OT type needs to go away. Maybe we don't. Okay, so a little better. Let's go back and check that copy. What a pain. Still have the wrong size here. We're 4 bytes off. I don't think that's... oh, no, that's... Sorry. That's just the stack at the moment, so that's fine. Looks like the stack is correct, just the wrong order. So let's move some things around and see if we can get the right thing. Still have some variable issues, but not as bad. And that looks like that was all that was necessary. Just moving that to the right spot. Okay, so draw env looks like it's, no, like I said, clip was offset 74. No, draw env. Dr env is S8. It gets such a nice register. High up on the priority list, maybe. I actually don't care. Oh, SB30 looks correct. Nope, 34. Trevor asked, do I use Ghidra at all? Sorry, missed it. I do a bit, not a ton. I wouldn't say that it would be my first choice, but I have used it. So it looks like this correct. Yeah, there we go. That looks like it's in the right spot. So we're getting close. Let's find brightness. It could be that brightness is clamped. Or it could be that we already have the right register. It looks like brightness ultimately is getting written to S6, and that all looks correct. But it also looks like S6 may be up higher. Possibly. Maybe. Now we're in a slightly different predicament. We have cases where stuff isn't being spilled to the stack anymore that should be spilled to the stack. And that that is its own issue. And so we have to deal with that as well. So it looks like 7C prim index. Let's move that down. When things get spilled to the stack, yeah, I don't think that will make a huge difference. I would expect it to be right after clip. You should have contributed. Char said he was looking at Cyberdoll for Sega Saturn. I need to spend some time with Sega Saturn. I'm just not familiar with that architecture at all. And because of that, I just don't ever really do anything with it. So here, because that 0 is being used and being assigned to S2, there's a possibility that that was getting set to like X first. V would be Y though. What do we have as S2? RE2 underscore 3. So that's not the same. Just a coincidence. Spilling onto the stack. So there could be a few things. Let me check this. Greater than equals, less than equals. Those often cause issues. I've never seen anything like a null check, but this could be a not. This actually is getting written to the S8 register, but I think that's coincidental. Maybe not. Do I have S8? No. No, not possible. Maybe it is possible. Let's check the return value of this. Actually, we will have it in the context. It's a DR end. Oh, and that's S8. Oh. Not what I wanted. Now, possibly my DRN is always offset 7C. No, I get S7. No, that's not DRN, that's drawing. Where am I using DRN? Yeah, so now my DRN is getting loaded into 7C when it shouldn't be. Let's look for S7. See where that's being used. 114. Entity is S7. Let's put that in its place. No improvement. Or yeah, the instruction set is just not something I'm used to. Variable instruction sets in general are not what I'm used to. Checking on the PlayStation. Ooh, I did something right. Still have some registers around 103. So let's focus the attention there. It doesn't necessarily mean that that's where the problems are. It's just possible that's where they're. There's a couple things. So how would you write this if you were actually going to be writing this in like modern day? Probably assign it to a literal struct instead. In this version of GCC, so we could say cast this as a rect, and then we're going to have a rect or a struct literal. And I like can actually use this syntax. Oops, what did I do? Got rid of the wrong thing. That's okay. Let's go back. Let's start over. I can program sometimes. We say clip equals rect, and then do .x equals 0. Not smiley face, but that would be fun. And so nowadays, this is more common. At least this is what I like to do. Maybe you don't like to do that. Blew up. Why do we blow up? Because GCC of this vintage says, look at all this data. This is just data. I'm going to go throw it in the data section. And so even though we had this nice local copy of all these values, and even though this is semantically the same meaning, the compiler doesn't generate the same thing, and so we can't do that. But that's not where the problem was it? Oh, and this is interesting. So we have a difference here. And I usually make PSP the exception. It doesn't have to be. Where do those nasty register differences go? They're up a little higher. I was looking at the wrong one, but that's fine. Let's grab this and look around here, case 1 on PSP. Let's see if there's anything we can find. So the first thing that's notable is the S7 versus A2 register assignment. One of two things could be happening. We could be assigning current buffer to a local variable. The A register suggests that it's not, but it could be. We could try it. So we need a GPU buffer pointer. I'm guessing that's going to not go well for us, but we could see. And it might not be that. It might be something else. So talk about that in a little bit. So that exploded our stack and didn't generate the right thing. So not that. What else could this be? Oh, I was on the wrong line anyway, but it doesn't matter. We could be grabbing draw as a variable, but I don't think that's what's happening either. Oh, what about down here? 107. Yes. Oh, if it's done one place, it's probably done another place. And are we missing it up here somewhere? Or is it just broken? No, it just immediately before, and it's not that way up there, which is, or down in case 2, which is strange. Was that it? 285, again, that's kind of an odd difference. The immediates are not usually terribly important if they're symbols. 73, this is going to be the same thing. Makes me feel a little better that it's even. Again, that means it's most likely just immediate values. This is the one time where it's not. We only get one instruction that's broken. But then we have it again, that's fine. These are just backwards arcs. And I should have known because this is how the other one is. We're getting it done. This may be it. We have all these nice types, and then we just get a big array of 32-bit values. Oh, did I fix one and break the other one? Don't tell me that this is plus y. Oh, not plus 7, of course. Nope. Oh, what register it goes into is wrong. Ah, fun. No, it's the args, the arg order. But why isn't it wrong in this one? So it's the last add, which needs to be this y value. And y is S3, right? Yes. And so I would expect that changing the order of those would... Well, let's do this. Let's take all these, copy it down here. It could just be because the difference there, the registers are wrong. No, that didn't help either. And it's that same way everywhere. Why? Okay, let's move it to the back again. There could be one other slight difference, but I can't imagine that that's what it would be. And this doesn't generate anything different. Okay. Much better when it's consistent. Let's just check the PlayStation version again. I don't think that's going to change anything. Still register issues up here on 104. What is our type? Those seem fine. So it looks like those are the only issues left, and what a crappy issue to be the last one left. What affects the order of the operands to this addition? Addition is commutative. It doesn't matter what order those are in. We want V1 to be second, and so you would hope that forcing it to be second would be what works. But that isn't working. The registers are being used exactly as I would expect. It's definitely strange that changing the order of that operation doesn't change them. So what else could be going on? Could there be type issues? Possibly. Could I have gotten this order wrong? Probably not. Oh, could I have gotten these globals wrong? Possibly. But I don't think that would matter. Okay, so when this happens, usually there's some unexpected case. So it could be like down here, there's these checks for less than 0. Less than 0 is a pretty easy one, not too concerned with that, but we should check all of the greater than, less than checks to see what they might be. So it could be, for example, that one of these is actually a greater than equal to. And so you'll get the same constant generated, but the way that the registers allocated changes. I'm going to try it here just in case. And then I might have to take this offline for later. So the number that gets generated here is 81. But usually we won't have a greater than equal to 81. That introduces other issues, which is why we need to get those right. But it is also why those could be the cause of other errors. There's a weak possibility that these are less than equal to -1. I don't think that's going to be the case. But I'm going to have to probably leave this unsolved. I think that the PlayStation version... Oh, no, PlayStation version isn't even matching, is it? Now what did I do? Oh, I need to fix this. Yeah, so it looks like I'm running into the same issue, probably, or the same root cause over here. Not what I want to see. Let's look at this. 106. That was the mistake here. And my guess is that this is correct now. So maybe that's all it is. Maybe I missed this. So 106, line 106. And scanning sometimes is hard. And I might miss a small change. No, it is supposed to be 256. So that's another difference between the two versions. So that I have some success today, I'm gonna take this and let's see if it compiles. So we need to grab all of our declarations. Ooh. I do want to write it. So I did a big rebase, and I think that's what this file was open when I was doing it. Need a few other declarations here. Oh no, we have those already. Bug. Can't redeclare it. So I'm going to have to cast it. That does point to, though, that being wrong. And that might be okay. Maybe that's what the issue is. I should get that one to match. Let's see how we do. Correct. So we have a an entity extension that I'm going to need to pull over. The entity extensions, unfortunately, require everything to be recompiled. So it's a slightly longer process. But let's let that cook and see. Looks like I have a symbol that's missing. Excuse me. It's that and Fingers crossed. Didn't work. Not a lot wrong, which is good. So what this is telling me is that all of the instructions look about right. Looking at the first section, there's some... Let's see if we can tell where this first line goes wrong. There's some data that's wrong. So possibly the jump table is wrong. There's an extra entry in the jump table. And 1B80 goes to the same place as the first entry in the jump table. Maybe? No, not quite. We have some extra... missing some data. But it could be related, again, to the jump table. It looks like strings. No, jump table. So there, yeah, it looks like there is maybe a case missing from the jump table. We have one missing offset here. That doesn't look, though, that looks like string. We have one too many offsets. Yes, this is a jump table. No, we're missing one. Sorry, top is theirs, bottom is ours. We're missing one offset, and that offset goes to 1354, which looks like it's the last it looks like maybe a case 7 that breaks. So that was a slight improvement. But now we have one too many entries in the jump table. We have an earlier case, maybe that's not doing anything, or maybe the fall through is not correct. No, that couldn't be. So let's do this. Let's go back here. The PSP may be able to help here. We could do an object diff, and this does tell us that our RO data is slightly wrong. And let's look at these. RO data offset 0. Offset 4. 8. C. $10, $16. $14, $18. And there is no more. And our switch code is just going to the jump table. Let's see if we add a case 7 if that does anything. Makes it worse, because now we have an extra RO data. Hey, Supreme Umbrella, good to have you back. I'm about to be gone. So there's still something wrong. It looks like either a string is incorrect, or Or I know for sure there's a file split here, and the file split may be causing this. So what happens when we're generating jump tables? I should have thought about this first. It's obvious in retrospect. When you're generating the jump table from code, the alignment is going to follow different rules depending on whether that jump table is part of the RO data section of one object versus a larger object. And right now, I know that there's file splits in here, and it seems like this may be the end of this file, and or it's part of I know that it's a different file from the functions above it. So I'm probably going to need to do the split and try it again. That isn't what's wrong though with the PSP version, and that's going to require something else. Because I know that what I'm using as the pause global is a pause, my guess is it's related to that, and I should be using X and Y here to get at the value instead. That may be the difference. Let's try. I shouldn't, but let's. So we're gonna take pause. We're gonna make it actually a pause pointer. We have to go fix our declaration down here, and this should help because it allows me to get rid of the ×2. And here we're going to do .x.val and .y.val, and we can get rid of the ×2 there as well. And we're going to have to do that for all of them. I wish there was a better way to do this. Most of my editors I can edit in columns. I need a pointer. Oh, this would be nice if this works out. I don't know that it will, but it still won't solve the other issue, which I'll have to come back to. And we should be able to take this and this is much worse. Of course it is. Why wouldn't it be? Because here we're probably dereferencing this instead of doing the stupid pointer arithmetic. Yeah, but that's still wrong. I was really hoping that that was going to be the right thing. But it's not. And the issue here, and this is why I thought it was a sine 32, the shift by 2 here basically is a multiply by 4, and that's what you need as the stride of your sine 32 array. Bummer. Okay, well. So 2 issues, one on the PlayStation, which is we're looking at the wrong file, and then one on the PSP, which is register allocation. So I'll probably work on this a little bit later, and we'll see if I can come up with the correct answer. So we're close, but not quite there. You've been watching somebody try to decompile Castlevania Symphony of the Night, getting most of the way there. We're working on Olrox in Olrox's quarter. This is the transformation between Olrox's human-like form to his true form. That's BO0, in case you don't know what all the overlay names are, all the files on the desk. Go to soten.z.dev to learn more, and I'm going to be back. Congratulations, Supreme Umbrella, on the third year of EE. EE was hard. I was a software engineer. I did touch a bunch of hardware, but then we had to have a focus, and I chose electrical engineering as my focus, and I sucked at it. That was hard for me, very hard. So definitely good luck, and you are a more intelligent person than myself, for sure. All right, that's it. I'll see y'all tomorrow. Adios.